Assalamu alaikum students. Today we are going to study periodicity of properties. The question is, what do you mean by periodicity of properties? And how the trends or periodicity changes along the period and down the group? Today our lesson objectives are: we have to understand periodicity of properties properly. Then we will be able to define atomic size and shielding effect. And then we have to relate periodicity of atomic size, nuclear attraction, and shielding effect. What is periodicity of property? You all already know that repetition of properties of elements after regular interval is called periodicity of properties. Elements show similar variations in properties along the period and down the group with increasing atomic number. That is, with increasing number of protons, they show a slight variation in their properties. This trend in period and group is called periodicity in properties. Let's see how we can measure the atomic size and what is the periodicity of property in atomic size or radius of an atom. As you know, atom is very small and don't have definite boundaries that fix its size, so it becomes very difficult to measure the size of an atom. Then how to measure atomic radius or atomic size? Assume that atoms are spherical in shape. When they lie close to each other, they touch each other. There are two ways of finding atomic radius when there are similar atoms and non-similar atoms. For similar atom, what we have to do? By using X-ray, distance between the nuclei of two adjacent and similar atoms can be measured. Consider it is equal to 2R. By dividing it with 2, we can calculate the radius of a single atom. For example, the distance between two nuclei of carbon is 154 picometer. It means its half distance would be 77 picometer, and it is the radius of one carbon atom. Picometer is the SI unit for the atomic size. Half of the distance between the nuclei of two similar atoms is referred as atomic radius of an atom of that element. How we can measure the atomic radius when atoms are non-similar? For non-similar atom, when we determine total distance between two adjacent atoms, which is equal to R by using X-rays, the radius of known element R is subtracted to determine the radius of other atom, whose radius is to be determined. For example, when there is a bond between carbon and hydrogen atom, the total distance between carbon and hydrogen atom is measured 114 picometer, while radius of carbon, as we know, is 77 picometer. So radius of hydrogen can be determined by subtracting its value from total distance, and we get 37 picometer radius of hydrogen atom. Points to be understood well. Inside an atom, there is a force of attraction between nucleus and electrons, called electrostatic force of attraction. Greater the nuclear charge, greater will be force of attraction. You may say that greater are the number of protons, greater will be the force of attraction for the outermost or valence shell electrons. Similarly, there is a force of repulsion between electrons. Greater the number of inner electrons, greater will be the repulsion between inner shell electrons and valence shell electrons. the force of attraction which must be felt by valence electron is decreased due to repulsion between inner shell and valence shell electrons. This reduced attraction is called effective nuclear charge or effective nuclear attraction. Thus, properties of elements depend upon net forces of attraction and repulsion. For example, when forces of attraction are stronger than repulsive forces, electron will come closer to the nucleus. And when forces of repulsion are stronger than attractive forces, electron will not be able to come closer enough to nucleus, and effective nuclear attraction will decrease. Let's see periodicity of size. Atomic size along period. When we move from left to right in a period, atomic number increases. Effective nuclear charge also increases due to increase in number of protons, and it pulls valence shell electrons towards nucleus and thus atomic size reduces. For example, when we study the atomic size of second period, in second period there are 8 elements: lithium, beryllium, boron, carbon, nitrogen, oxygen, chlorine and neon, and their atomic number are from 3 to 10. You can see that their size is decreasing from lithium to neon. The atomic size of lithium is 152 picometer, while atomic size of neon is 69 picometer. This shows that atomic size decreases along the period. Now, atomic size down the group. Down the group, number of shell increases along with addition of electrons in successive periods. The effective nuclear charge decreases due to greater repulsive forces. Atomic size increases. For example, when we study the atomic size of first group contains hydrogen, lithium, sodium, potassium, rubidium and cesium. Atomic size of hydrogen is 37 picometer. It has only one shell, while cesium, which have 6 shells, have atomic size 265 picometer. Although the number of protons are increasing from 1 to 55, but it does not show much attraction toward the valence shell electron due to increasing repulsive forces between valence shell electron and inner shell electron. That's why instead of decreasing atomic size increases. Let's see again trends in atomic size of normal elements. Atomic size decreases along the period with increase in nuclear attraction, and atomic size increases down the group due to increase in number of shells. But the trend change in d block elements or transition element. Let's see trends in atomic size of transition elements and d block elements. The size of atom does not decrease regularly in period which have transition elements. For example, when we move from left to right along the fourth or fifth and other periods which have d subshells, the atomic size first reduces and then it increases due to presence of d subshells. Now we are going to study shielding effect or screening effect. As you know that there is a repulsion between inner shell electron and valence shell electrons, this repulsion shields or screens the actual nuclear attraction. This reduced nuclear attraction is called effective nuclear charge and represented by the symbol ZeFF. The electrons present in the inner shell screen or shield the force of attraction of nucleus felt by valence shell electron is called shielding effect. What is a shield or what is a shielding effect? Consider this is a shield, and it is not allowing the electron to go inside of this shield. Similarly, shielding effect don't let the valence shell electron come closer to the nucleus. With increase in inner shell electron, shielding effect increases and thus reduces effective nuclear charge. While if number of inner shells are same, like in a period, then apparently there is no change in shielding effect. So effective nuclear attraction increases towards the valence shell electron, which in turn reduces the apparent shielding effect. Shielding effect along a period. Along a period, shielding effect remains same as number of inner shell electron remains same, but effective nuclear charge increases due to increase in number of proton, and valence electron come closer to the nucleus. This increase in nuclear charge decreases effective shielding effect. For example, you can see the elements of lithium, beryllium, boron and carbon. Their atomic size reduces as the shielding effect in them is same, that is, inner shell is the same, K shell, but their size is continuously reducing due to increasing nuclear attraction or electrostatic force of attraction. Let's see shielding effect down the group. Down the group, as the number of inner shell increases, it decreases the force of electrostatic attraction between nucleus and outermost electrons. But increase in inner shell increases shielding effect. So bigger size atoms have greater number of inner shells, so they have more shielding effect. Let's summarize it. Atomic size decreases along a period due to increase in nuclear attraction, and it decreases shielding effect along a period. Atomic size increases down the group as nuclear attraction decreases due to successive addition of shells, and shielding effect also increases. Review. Today we have studied periodicity of properties. We defined atomic size and shielding effect, and also we had related periodicity of atomic size, nuclear attraction and shielding effect. That's all for today's lecture. Thank you.